And we're back. We have this light interaction with matter. We have our transparent, our translucent, and our opaque objects. Transparent allows almost all the light to strike through, and there's that clear image. So we have our clear window or glass, biscuits tank, air, plastic wrap, the plastic water bottle. Translucent allows most of the light that strikes it to pass through, but the image is going to be blurry. So our examples we discussed were the frosted window. There's wax paper, tracing paper, parchment paper. What we said, stained glass. And then opaque was when we watched that video to show the scattering with the milk. And there's black construction paper, aluminum foil because it reflects. It doesn't let things through. Book. We did that class activity, and there was a rock and a brick or a cement block, a wooden block, a desk, a tree. I think we said humans. Those are materials that do not allow any light to pass through. They're opaque. Light waves are measured in nanometers. We know that from when we just filled in that table from the electromagnetic spectrum there with the light waves right here. We see different colors because objects are going to absorb or reflect different wavelengths. This interaction, when it absorbs some of it, we don't see that color, and when it reflects that wavelength, that's the color we see. It reflects it to our eye. So a red rose is going to reflect red wavelengths and absorb the others. You know, a yellow banana will absorb everything, but the yellow will get reflected back to our eyes, or the orange, the fruit, will appear as orange because orange is reflected back to our eyes, and the rest of the wavelengths are then absorbed by the orange, so we don't see them. If we see white light, it is a reflection of all of the light, so all the wavelengths in that spectrum, and if it's black, it's because it has absorbed all of them. Light travels away from the source in all directions, so you can see that here it's going in all directions away. That's why lamps, like Biscuit's lamp, has to have this casing on the top to then direct the light down, or else we've wasted a lot of it. These terms, when it says be familiar with, it's kind of just like the definitions of refraction. We know that we change direction because you are changing the speed as you change the medium. Reflection is those light waves that come in contact with the surface of the material and they bounce back off, like a mirror or aluminum foil, chrome of a car. Diffuse reflection, that's going to be the opposite of your normal reflection. Your diffuse reflection here is when the surface isn't smooth. The light waves will come in and they'll hit that rough surface and it's going to come out at some random various different angles. Whereas scattering is also kind of a similar concept, but here we've got those dust particles in the air was the common example where the light's going to come in one direction and it's going to hit those particles and it's going to bounce back, some back where it came from, and then others kind of random directions. It might then hit another one of the particles and then go the other way, that way, and so they scatter, like cockroaches would when you turn lights on. And then a normal line is it's that line that's perpendicular to the reflective surface. So that's going to be right here. You guys are familiar with the incoming incident ray and the outgoing reflective. We know that law where these are going to be equal angles right here. You guys really have that part in the bag. This ear right here, we've got the anvil. It's going to be that small, one of the small bones here in the middle ear. We've got the stirrup here, kind of looks like a little stirrup, like on a horse saddle. Okay. Our cochlea is that thing that looks like a snail, or like Gary off of SpongeBob. The eardrum here, that thin membrane. Here's our ear canal. And then the hammer is the third of those tiny bones there in the middle ear. The outer ear is going to be the organs on the outside of the head. That video I know had said the pinna. Our text did not mention that word, but the video did. as well as the ear canal, which funnels or collects or channels that sound then into the ear canal. Where it goes to the middle ear, the eardrum vibrates those three tiny bones of the hammer, anvil, and stirrup, which amplifies or magnifies that sound. And then the inner ear with that snail-like cochlea, it has the liquid and the hairs in it, and they're going to convert the vibrations to nerve signals that then go to your brain, because your brain cannot interpret the vibrations as any sort of sound. They're still just vibrations until then those nerve signals can talk to your brain and say, I hear, something annoying or pleasant. And then here with this path with our guitar, these guitar strings are going to vibrate, and then vibrations are going to come off, and they're going to travel through the air, and we've got the air particles, and it makes that domino game, which then is going to go through the air to those pinna, the outer parts of the ear that are sticking off of your head. And then that sound is channeled or funneled in through the ear canal to the middle ear. It's going to hit that thin membrane of the eardrum, which is then going to pass those vibrations onto our three tiny bones there, the hammer, anvil, and stirrup. The vibrations are then going to go into the inner ear there with that cochlea. The middle ear amplifies it, and then the cochlea is going to then take those vibrations and transform them into nerve signals to send them not to your big toe but to your brain, where you can then register it as sound. So I hope that was helpful. I hope you are able to stop it, pause it, back up, make corrections, modifications, additions. Shoot me any emails if you have any questions or comments or concerns. Again, you can use this tomorrow. Your study guide, nobody else's. The one that has your name on it is the one that you may use. I know that we know this stuff. It's been a real quick chapter, but pretty enjoyable. And I just want you all to know how much I really love and enjoy having you in class. Thank you for sharing your hour a day with me in science. And again, shoot me an email or a Canvas message with any questions, comments, or concerns. Other than that, have a wonderful Wednesday, and I'll catch you tomorrow.